Hey guys, welcome to today's video where we'll be talking about water and hydrogen bonding. Water is a very important aspect to life. It is actually a universal solvent. If you guys see, I have it written here. It is a universal solvent of life, and it is the most important molecule for biological systems. Now, as far as water being a universal solvent, this means that many other things can be dissolved in water. An example, salt, sugar, and many other things that we use get dissolved in water, which water is the solvent. Water is very important in a lot of these biological systems. We see it happen in photosynthesis, where water and carbon dioxide are needed to help the plant go through its processes to make its own food, right? We have glycolysis and many other reactions. If you guys look at other videos that I've made, we talk about dehydration reactions and, certain reactions where water is needed, right? So again, this is why water is important. It really drives a lot of the biochemical reactions that happen in biology. And up here we have some structure up here, H2O. So we know that water has two hydrogens and one oxygen. And if we look even deeper, we have the electrons here for oxygen and then the two hydrogens that it's connected to. Now, in the last video, I talked about electronegativity, right? And what we have here is, if we draw this arrow means that all of the electrons are being pulled towards the oxygen. This is because the oxygen is more electronegative than the hydrogens. So this oxygen is very greedy and it reacts. So if we look at our ball and stick diagram right here, we can do the same thing here, where this oxygen is more electronegative than these two hydrogens. So all the electrons are being pulled towards that oxygen. Now, why is this important? Well, if we go over into our next slide, we have two water molecules here. And let's just peek at the periodic table down here where we have hydrogen and then we have oxygen. And again, in the last video, we talked about if we were to move this way, right, to the right and up, more electronegative that element is. So of course we know that oxygen is way more electronegative than hydrogen. So now what happens is, how would this react? Let's just say there's two water molecules that are floating, just floating around, right? How would they react? Well, again, if we look at electronegativity, we know that this oxygen is more electronegative than the hydrogens, and it's attracted to the positively charged hydrogens. So what will happen is this oxygen will go for that hydrogen. And the same thing can happen. It's pretty cool, right, guys? I can copy and paste this. If I copy and paste another one, what will happen? This water molecule follows this one, and then this one can go ahead and attack that hydrogen there. And what we have is kind of like some sort of like a ladder. So if we see in this image here, right, we have hydrogens that can, water molecules that can attach to different hydrogens of each water molecule and ultimately kind of create this net where they're tightly packed together. If we go into our next slide, I want to talk about properties of water. Some properties of water involve cohesion and adhesion. So let's start with cohesion. So cohesion is basically saying that hydrogen bonding allows for these molecules to stick together very tightly, right? Now, this allows for lighter objects to float on water, i.e., or an example, a leaf, and we even see bugs kind of float on water. Why? This hydrogen bonding creates surface tension. These water molecules are so packed together, we see here kind of like a net, that anything that's lighter than water can float above it. Another very interesting thing that I want to bring up is, why does water not flatten out? Now, when we see water and there's like a droplet, it doesn't flatten out. The reason being is because of cohesion. These water molecules tend to want to be together. They drag each other. So they form this little droplet here. And I don't know if you guys are familiar with this, but there's a TikTok out there where they continue to add water to into a glass, and until that water is like gets topples over, then that person loses. And it's like, wow, we keep adding water, how come it's not flowing over? And this is because of cohesion and these water molecules really wanting to be together. So now if we go into our next slide, I left the definition for cohesion up here, but what I want to get into is adhesion. And adhesion is another property of water, and this is when water is attracted to a different molecule. So in cohesion, that's when a water molecule is attracted to another water molecule. However, adhesion is when a water molecule is attracted to a different molecule. And I have a very cool picture here that I think can kind of explain things, right? So with cohesion, we see it's between water, as seen right here in the middle. So this is a water molecule, and this is the second water molecule, and they're joined together, they link together. Water with water, cohesion, they're tightly packed. Then we have adhesion, where molecule 2 is tied to something different. It can be anything, right? I do have an example in the next slide as well. And then we have water molecule 1 that is packed right to our right with some other type of molecule. So if I can just move this out the way. Oh man, 1 second, there it goes. All right, so that kind of gives you an idea, a little cool picture of, how adhesion and cohesion differ. Now, with the electronegativity of oxygen in water, this causes high attractiveness to other surfaces. So now we kind of get in this pickle where would water go? Does it stick to another surface, or does it stick together? Well, ultimately they stick together. However, if there's a higher affinity for another type of surface or molecule, it will do just that. An example is in capillary action. And capillary action is the movement of water through a plant. So we're all aware that plants need water. And how it starts off is water uptake comes from the soil to the roots and basically through the tree or plant, right? Now, what we have are these water molecules that like to be together. You can see here they're all lined up. Even off to the left, we see where they're like in a chain link here. They all want to be together. But they also are initiating adhesion, where they're doing this to the cell wall of the plant, where there is an affinity there, where it actually prefers to be joined with the cell wall. So if we look up here, there's a fight between cohesion and adhesion. So water molecules are more attracted to the plant tissue, right? And this is mainly because the forces of adhesion are stronger than the cohesion, correct? And again, this is all because of that oxygen atom that is highly electronegative and has an affinity for another molecule that is more partially positive, right? And then another cool thing about water is it brings its buddies too. So as these water molecules are moving up the cell wall, it will bring the rest of its friends up, and this is very important for the plant. So this kind of gives you a quick idea of water and hydrogen bonding, some of the properties of water, and why it's important to biological systems, all right? So I hope you guys enjoyed the video. Take it easy. I'll see you guys next time. Peace.